Hi guys, welcome to this video session. In this video we are going to see about the working principle of thermit welding and explosion welding. Explosion welding. Explosion welding is a type of solid state welding process. In this process, welding is accomplished by accelerating one of the components at extremely high velocity through the use of chemical explosives. This clearly explains the working of explosion welding in details.
Explosion welding is one of the joining methods consisting of a solid-state welding process in which controlled explosive detonation on the surface of metal is done. During the collision, a high-velocity jet is produced to remove away the impurities on the metal surfaces. Flare plate or cladder collides with the base plate, resulting in a bonding at the interface of the metals. The metal plates are joined at an internal point under the influence of a very high pressure and causes considerable local plastic deformation at the interface, in which metallurgical bonding occurs in nature and even stronger than the parent metals. Here, we have to note a point that the plastic deformation is occurring over here. One of the features of this welding process is that similar and dissimilar metals can be joined by this process. Diagram and working animation. This is a schematic arrangement for explosive welding. The main component in this welding process are: first one, this is parent metal or base plate. We put it on the anvil. Above it, we put a flare plate with some gap which is called standoff distance. It is placed using guided pins to keep the uniform gap in between both the flare plate and parent metal. And right above it, we put some explosive uniformly. It is utterly important to decide and calculate the quantity of explosives and velocity of explosion. Later, detonation is started by using detonator switch, and it is also important to start detonation from one end of the cladder. Then the detonation moves upon the upper layer of cladder at the uniform speed, and this explosive front progressively drives cladder plate downward to the base plate at a very small collision angle caused by the standoff gap. Due to this, a high velocity plasma moves in the direction of detonation, which forces the impurities and other oxide to get removed between the plates, which makes the high quality of welding possible. Important fact: we could attain a pressure of 2 million pounds per square inch of pressure using this.
Thermit welding. In this welding, there is no external heat source is required. During this welding process, heat is produced because of an exothermic reaction, and thus this heat is used to weld two metal pieces. This animation shows the working principle of thermit welding. Thermit welding mainly consists of crucible and molds. The crucible is made up of sheet iron and lined with magnesium in the inner side. Magnesium stone thimble, which provides passage to the molten metal, is fitted in the bottom of the crucible. The crucible stores the thermit. Thermit is the mixture of aluminum and iron oxides. Mold is prepared according to the shape of the workpiece. Before preparing the mold, the wax should be poured into the gap which is used to be welded for perfect molding. Mold has pouring gate, riser and heating gate as with cork. After fixing the mold over the workpiece, the thermit in the crucible is ignited to 1200 degrees centigrade. On heating this mixture, the oxide in the iron are liberated and combined with the aluminum metal. It is well explained through this chemical reaction. Before melting the metal in the crucible, the wax which is joined is melted and the inner of the mold is dried up by firing using the gas welding flame. After firing, the heating gate is closed with a cork plug to prevent the escape of the molten metal. At 2500 degrees centigrade in crucible, the thermit starts pouring its molten metal through the thimble to the pouring gate in the mold. The molten metal fills the gap in between the workpiece and goes to the riser and to slag basing. The excess molten metal is stored in the slag basins. After solidification of the molten metal, the workpiece will be welded. Finally, molds should be removed and the extra portion of the weld is removed using the grinding wheel. Thermit welding finds its application in repairing railway tracks, welding of crankshaft in the large locomotive frames. Main advantage in thermit welding is that very large surface can be welded. Main disadvantages in thermit welding is that only ferrous metal can be welded. And the other advantages of the thermit welding, it is a simple and fast process of joining. This process is cheap and no costly power supply is required. This process can be used in the place where power supply is not available. And the disadvantages are thermit welding is essentially used for ferrous metals. It is uneconomical for welding cheap metals and light parts. Applications of thermit welding. This welding is traditionally used for welding of very thick and heavy plates. It is used to join railroads, pipes, and thick steel sections. It is also used in repairing heavy castings and gears. Thermit welding is used for welding cable made up of copper as well.